overview of these interesting
Thanks to you.
Analyses. So next we move to the discussion panel for the asynchronous talks. And just as a reminder, the presentations of all of these different talks have been uploaded to YouTube, and you can, in case you missed them, you can watch the videos there. And yes, this is a discussion panel, and we invite you to write questions to each of the people presenting, which are listed here. We ask that when you ask a question, you please be sure to specify who the question is for. Yeah, and I think that's basically it. We will start with each of the panelists can introduce themselves and give a 1 to 2 minute overview of the results that they showed. So I think it makes sense to go top to bottom. So Alexei, if you're there, please feel free to start.
So do you hear me?
Yeah.
Okay. So this workshop, I am presenting result of precise test of lepton flavor universality in epsilon-3 as decays to tau and muon pairs with the Bobar experiment. And this is based on about 28 inverse femtobarn data collected at epsilon-3s in 2008. So, and final uncertainty, total final uncertainty is about 1.5%, and result is within 2 sigma with the standard model prediction with radiative corrections. Of course, radiative corrections are small for this decay. And this result is about 1 order of magnitude more precise than the only previous Clio result. So Clio had about 10%, Bobar has about 1.5% total uncertainty.
Great, thanks. And next we have with rare decays at LHCb, Jacopo.
Yes, can you and me?
Yes, I hear you.
Cool. Yeah, hello everybody. I'm Jacopo, and I'm a member of the LHCb collaboration. I'm a PhD student in Marseille, France, and my talk indeed was about the recent developments in rare decays at LHCb. And I covered the most recent results in this field, in particular some very hot topic now, let's say, the measurement of RK and the new measurements of the BS and B to mu mu decays, and also the branching ratio measurement of the BS to phi mu, and also I presented some angular analyses, in particular the new measurement about the angular analysis of BS to phi mu, and the other B to K star EE and B plus to K star plus mu. Thanks.
Thank you. Patrick?
Hi. Can you hear me? Yes.
Yeah.
Yeah. Okay. Hi. So I'm Patrick Adlerson, and I'm representing the BESS3 collaboration. I am researcher in Uppsala, Sweden, and so most of the CP violation studies that we have been presented at this conference have been about mesons. And at BESS3, we can make complementary measurements by studying CP or performing CP tests of baryons. And also we can produce these heavier baryons, so hyperons, in the strange sector by in pairs. So we produce barium, anti-barium, and study their decays. So there have been some recent methodological developments which allows us to make a simultaneous and direct test of these weak decays of hyprons. And what's interesting also is that what I presented was a result that we just pushed to archive just a few weeks ago. And what's really interesting is if you study weak decays, which are going sequentially, so cascade particles, which decay to a lambda and then further on to a proton. If you study the cascade minus and cascade bar plus decay exclusively, so you measure all the final state particles, you can, it's very rich mode, so you can do many studies. And in fact, we can measure the weak phases of the cascade minus decay parameters. So this is the first weak phase measurement of any barium. In addition, these types of CP tests were proposed 35 years ago by John Donahue, and only now with these types of measurements have we been able to measure these CP, make these CP violation tests. So that's what I talked about.
Thanks. And Peter?
Yes, can you hear me?
Yep.
Right. So the topic of my talk is tau physics prospects at BEL2. And this contains some preliminary measurements we have done on early data, as well as sort of a summary of some highlights regarding prospects. So regarding measurements, I presented this recent measurement of the tau mass on the 2019 data set, which still has quite a large uncertainty, in particular the statistical uncertainty, although within these uncertainties, it's consistent with previous measurements, for example, from VES and BEL1. Then regarding prospects, I discussed sort of our plans for measurements or tests of lepton flavor universality with taus, the tau lifetime measurement, and the various searches for lepton flavor and lepton number violating decays. For example, the search for tau to 3 mu or tau to lepton alpha. Right, yes, yeah, so that's more or less what was in my talk. Okay. That's all from me, thank you.
Thank you. And Rahul?
Yep, hope I'm audible well.
Yeah.
Yeah, so hi, I am Rahul and I'm a PhD student from TIFR Mumbai, currently working with the BEL2 collaboration. So in my talk, I have discussed measurements and prospects, results and prospects of radiative and electric penguin decays at BEL2. So I have basically briefly summarized why these decays are an excellent probe for indirect searches of beyond standard model, new physics, and also precision measurements of the standard model predictions. So followed by that, I have discussed preliminary results of B2SLL and B2X gamma decays from the early BEL2 data. And in the last part, I have also talked about the B2K nu bar missing energy decay. So there has been a very wonderful analysis on this mode using a novel experimental technique. I should say everyone should have a look at that. And with an order of magnitude low data compared to the previous measurements of Babar and Bell, we have reached branching fraction measurements, which is compatible to the previous studies. So that's really good. And followed by that, I have also discussed the prospects of how with increasing data, we can improve the analysis techniques and hope to provide better results on this frontier. Thanks.
Thank you. And Sophie?
Hi, so I'm Sophie Hollett from the Technical University of Dortmund, representing LHCb. So we've had lots and lots of different results for mixing and CPV at LHCb in the past 6 months or so. It's been a very busy time. As a highlight for CHARM in particular, We had our official result on Tuesday that I gave a preliminary overview of in the recorded talk, which is this mixing of neutral D mesons. This is the first measurement of the mass difference between the two D mesons. The first official measurement of this X that exceeds 5 sigma, so that's exciting. And we have 3 other CHARM CPV studies as well. This has been an exciting field since the first CPV result in 2019. And there's been so much going on in beauty as well. We have mixing results for the B sub S meson. In fact, we have 2 different results. Both of them were the most precise result at the time. And we've had some measurements of the gamma CKM angle, some more studies of the K-pi puzzle related to B goes to K-pi type decays and the isospin relations between them. We've had some CP violation studies in the baryon sector. And of course, another hot off the presses type result in the last 2 weeks is we have this study of B goes to J psi, sorry, B sub S goes to J psi phi, measured with J psi goes to 2 electrons rather than 2 muons.
Thank you. And last we have Jacopo again with, well, this time from NA62.
Yeah. Hello, I'm Jacopo. I'm a Marie Curie Fellow for NSCC2. And in this talk, I present the latest result of NSCC2 for the main channel, the experiment, the measurement of this very rare decay that is K plus impa plus neutrino antineutrino, and some upper limit about the lepton flavor and number violation paired with an NSCC2. Thank you.
Thank you. So I don't see. Okay, we have a question first for Patrick. If I understood correctly on slide 11 of your talk, the standard model predicts the size of the asymmetry for alpha, but from slide 10, it does not predict the value of alpha. Could you elaborate on this?
So on slide 11 of your talk, okay, so all right, so does not predict the value of alpha. I'm not sure. So of course there are standard model predictions for both. I mean, for all of these 2 body weak decays, you have standard model predictions for sigmas and for lambdas. And one of the thing is, so there are 2 things. One is the asymmetry parameter, and that's where we make these CP violating tests by comparing alpha to alpha bar. And so what has been the problem, first of all, with the asymmetry parameter of alpha was that there have been old measurements that were assumed by PDG, and everyone had just basically assumed these values. And what we found using these new methods that were developed, that the old value was off by 17%. So none of these measurements that I've done or that we have done at BEST3 indicate CP violation. So rather, what we have done is that we have shown now the methods that they are feasible, and we have a larger data set from BEST3, which we take in data with. And in addition, if we find no CP violation there, you have also future experiments, such as the super tau charm factories, where the desire is to go down to the standard model precision. I don't know if that answered the question. But
I guess if they didn't, they can follow up. We have a question from Slack for Alexi. Is a measurement of lepton flavor universality in E plus E minus over mu plus mu minus feasible? Is this not done because of BABA backgrounds?
Yes, it's I somehow stressed in my presentation that BABA background is really huge, and it will be very, very difficult to select electrons from epsilon-3s decays. So we decided to limit only muons and tau leptons, since yes, electron mode is highly contaminated by BABA process.
Thanks. And we have a question for Sophie. You mentioned in your talk that the CKM angle alpha is constrained by the beta pi measurement. Are you able to say what the impact on alpha is with the measurement presented in slide 13?
So this is a slightly tough question because the measurement of alpha depends not just on the CKM parameters we measure here, but it's based on a certain amount of isospin stuff as well. So it's going to depend on some other things. I've got the CKM fitter open in another window. So I was hoping I could find some information about what the last result in alpha was, so we could estimate the sort of effect we might have had from the improvement with this new result, but I don't happen to have it on me. Maybe I can reply to you in Slack later on.
Yeah, that's always an option. Right, thanks. Let's see if we have any more questions coming in. If not, then everybody will have to respond to my questions. Okay, I guess we have to respond to mine then. So I'll start with Jacopo, who presented on the rare decays. One of the new results that was presented today was, well, not today, but this week, was the BS to F mu mu. And I understand that this was just a first analysis with this mode, but do you know if there are plans ultimately to do an angular analysis, and how many more events would be needed?
Sorry, the S2 prime mu?
So
the F2 prime mu.
Yes, if there are plans for angular analysis, or if there's not sufficient statistics, or
I actually don't know if there are plans for an angular analysis of this mode, but I think it would be great if this was the case. But yes, I'm afraid I don't know if there are plans, but for sure I can maybe find information and reply on Slack.
Okay, yeah, it's maybe a tough question to answer. There was one thing I was curious about looking through it. Great, thanks. And if I can go to Peter now. I had this question on slide 12. Yeah, so I guess it's I had a few questions. One is if the PID is again expected to be the dominant systematic. as well for Bell2.
Yes, I hope you can hear me well. Yes, certainly it is. So we've already done some internal, very preliminary studies and estimations of the systematics. And our trigger systematics, which is the subdominant, one of the larger ones here, is well under control at Bell2, which is very nice. But yes, this is certainly the largest systematic. Many of the others cancel, but again, as was the case at Baba, we hit this limit of the particle ID. But we have many ideas of how we can improve our electron and muon identification efficiency measurements, and try to constrain this as much as possible. But this is basically the main limiting factor of this measurement. As I mentioned here, with only 100 inverse femtobarns, we can already match the Baba statistical precision. So I think there's a lot of work here, but once we get this under control, we're in a good shape at Bell2. But yeah, certainly this will again be the sort of main focus of this measurement, bringing down this lepton ID systematics.
Okay, thanks. And I was also curious on this slide, what's the what will allow you to use the one by one prong topology that they didn't use at Babar?
Right. So as you can imagine, having a fully inclusive one prong tag side, you have significantly higher statistics. But of course, you also have a lot more background. So I mean, there's a really nice potential measurement here, but again, it's quite challenging. And here, relatively straightforward cut-based selections is not sufficient to bring down the backgrounds. So here, I think we really need to rely on some machine learning techniques, and perhaps restricting to some of the cleaner tags, tag tau decays to bring this under control. But it's a lot of work, but in the end, it could be a very nice result. But yeah, here it's really a matter of bringing down the backgrounds.
Great. Yeah, I had a few other questions on you. I mean, it's great to see these all of the great plans coming forward from Bell2, but I guess I should move on. But I'll stay with Bell2 actually and move on to. Oh no, I'm sorry. I have a question from Slack before I ask Raul. For Sophie, maybe a naive question, but how seriously should one take this K-pi puzzle?
So fundamentally, the K-pi puzzle is about the fact that the isospin relations that we expect to be approximately true are just really not holding now at about 8 sigma compared to 5 sigma before. So in terms of new physics, maybe we shouldn't take it particularly seriously, but it's definitely a sign that the isospin relations here in the beta K-pi type decays are not telling us the whole story. And we need to keep investigating these in experiment to see if we can find any more holes in the puzzle. And we're really calling out to theorists to have a look here and see if they can find the pieces of the puzzle that we might be missing, that the isospin analyses alone can't tell us.
Thank you. And if I can go back to Bell2, I have some questions for Raul now, starting on slide 12. So I mean, it's amazing to see the improvements in sensitivity you're coming up with compared to much larger data sets. And for this analysis, this is coming solely from the inclusive tagger.
Okay, so I'm not in direct part of this analysis, but
Okay.
I would expect that with the inclusive tagger, we are getting a hold on the signal selection efficiency basically. But this nested statistical learning algorithm, which they have use of 2 BDTs with close to 50 discriminating variables, maybe that, and yeah, couple of more things should help us answer this, why we are improving the system, sensitivity here. Yeah.
Okay. And I had a small question on slide 13 as well, because I don't think I saw, but do you know what kind of constraints we have on the transverse longitudinal fraction at the moment?
Okay, I don't have an answer right now, actually. I might look up a bit on this.
No problem. And one other quick question for you on slide 15. So I didn't see, maybe I missed it, but I didn't see an estimate of the significance of the signal here, or a discussion of how much we should expect. Are these quantified or?
Okay. This also I have to check with the internal literature whether they have quantified or not. So basically, I picked it up from one of the slides, result slides. So this maybe I can, this and this FL question I can check and get back to you.
Okay, no problem. Yeah, it's very, very interesting studies, and excited to see the measurements as you continue to increase your data. If I'm just checking that we don't have more questions yet. No. So I would have questions for Jacopo for the measurement of the very rare KMs. Starting on slide 10. I was curious because you said that for this upper signal region that you only expanded it in 2017 to go from 35 GeV to 45 GeV. Was there some development that led to you being able to do this, or was it just having more confidence in the backgrounds? I don't know if you got my question.
Sorry, there was the Microsoft that was not working, sorry.
Okay.
Okay, so I start again. Yes, this extension for 35 to 45 was done in the last year, so that's taking 2018. And it was obtained from both stuff. First, was the better comprehension of the background, but even from like an update that was done for the upstream background. If you can go to the slide of the upstream background, I can show you one thing. There is tell you which one is the 12. 12. Choose slide after, yeah, and one before. Yes, you see there is this collimator in red. Sorry, I don't see the one the slide on the 12th slide on the upstream background, the one before this one. Okay, yes, perfect. This red box is a collimator that was added in 2018. This collimator helped to reduce depth, and so to help it even to improve even this signal region and to improve the acceptance of the signal, together to the better comprehension of 3 pi background and pi plus pi 0.
Okay, thanks. And if we could go to slide 17, I had just a few more questions.
Yep.
Yeah. So I was wondering because I don't, maybe I missed it, but what are the main sources of systematics?
Mainly done like background comprehension, and the main source is surely the upstream background, because we don't have a very big knowledge of this background, because we need a very big statistic, and however there are very few events that pass all the selection. We did this inversion of Sankat to study the background, but however it's not a very big statistic. It's just a big background in the end, because there are just few events that are similar to the signal that pass all the selection. So this is mainly, and mainly that principle.
Okay, and is this the sort of thing that you expect to scale with more data?
Not only with more data, but even improving the detector. Indeed, for this run that will start in 1 month and a half, we improved adding 2 main detector only to reject the upstream background. Even because if you saw is the main source of background, even the about of the 7 even of background, the biggest part is this upstream background, and so we added 2 detector to select and veto this background that we can use to select for to study it in with the control sample, but even to veto the background during the data taking. We are thinking to use it even in the trigger to reduce directly this background during the data taking. But however, even offline is a detector that are upstream of the K region and downstream the K region.
Okay, great. Yeah, so thanks for answering the questions.
Can I ask a question?
Yeah.
Do you know what is the status of KE2 decay ratios in Na42 for 40? Yeah.
The status of K in electron neutrino. This is the question.
Yes.
I know that for Na48, I don't know, but I know that someone is studying it even on Na62.
Because yes, Na48 had like small fraction of statistics, which now has Na62. So it.
Yeah. Now the main problem in Na62 is that the cut that we do at trigger time mainly reject a bigger part of this CDK, because if you keep everything is a very big bandwidth in the data taking. However, they're studying it mainly in because there is my colleague that is doing the study mainly to see the fraction between the branch ratio of K mu pi and K pi. So to see if there is
this ratio,
to see if there is sorry.
Yeah, I'm interested because this ratio is very well known in the standard model and very precisely known. And yes, and it seems you have infinite number of charged counts, so you can measure this ratio. Or it seems that there are some problems which prevent to do this.
Yeah, however, we are trying to study this ratio, and even, for example, the ratio with 2 muon and 2 electron. For example, for the lepton favor universality violation, to have some measure that can be complementary to the LXCB1 for them. So I'm studying already. I'm planning to improve the number of statistics that we'll have with the new run that is starting in 1 month and a half. Really, I hope that we'll have some result soon. about this duration.
Okay, thank you.
Thanks. So I have just one more question I'd like to ask, I guess, before we close. Was for Patrick. So you had mentioned that the very nice methodological breakthroughs that you had could be used for other decay modes, not just the strange baryons. But I was curious if you've also considered the sequential decay measurements with the omega baryons, or if it becomes too complicated with the higher spin.
We have measured them with BEST3. And that's done at the Psi2S resonance. So all these measurements have been done for with Jape Psi that I talked about. And there we have a 10 billion Jape Psi data sample. We published not so long ago on these determination of decay parameters, but it's more complex, but it's doable definitely. And now we're collecting more data on these higher lying charm resonances. So that's definitely coming more. There are definitely coming more precise measurements from us in the future. And I also want to. I reread my first question that I received, and I want to make a clarification. So actually, when you make these CP tests, the theoreticians calculate the strong phase difference and weak phase difference and multiply them. And that's how they get these CP violating observables. However, to get these asymmetry parameters, what has been done is that they used experimental input to determine these strong phase differences and weak phase differences. And those are old, yeah. So actually, there's a big need for more theoretical developments in the baryon or in the weak baryon sector. And so, if there are any theoreticians, we are very happy if you would help us to really set stringent new measurements on these baryon decays, weak baryon decays. So that's a shout out to all the theoreticians out there.
Great. Hopefully somebody is listening. Yeah, I could continue going on asking questions, but we're already, I guess, significantly over time, and maybe should free people. So let me just say thanks to everybody that presented today or that uploaded their slides and answered questions. It's really magnificent work everybody's doing, and it was a pleasure to watch. And yeah, it was a pleasure. So yeah, I think that concludes this session, and I'll just note that the last session will be tomorrow. Shoot, I guess there was one more question for Peter, which is, when should we expect the tau lifetime measurement to be released, and will the first analysis already improve on bells?
Yes, so this is let's say a very nice method we've developed with 1/3 point tau decays, which takes advantage of something kind of unique to Bell2, and that's this sort of tiny beam spot size we have near the IP. So because we can use 1/3 prong decays as opposed to 3/3, we get like a 5 times higher efficiency, and with this novel method, a 2 times better decay time resolution. So yeah, as I wrote in my presentation, we can expect already a competitive result of 115 the femtobarns, but we already have more data than this. And so it could very well be that this first measurement from Bell2 becomes a world-leading result. But let's see, we don't make any promises. That's always dangerous, but it looks very promising, I would say.
Great, thanks. And I didn't mean to close before if anybody had any questions left, but I guess this is last chance. But yeah, as I mentioned, thanks again to everybody for their talks and for joining today and asking questions, and hope to see you at the last session tomorrow. Yeah, so everybody have a good afternoon, evening, or night. Thanks.